Let's talk about your first exam. It's coming up soon, and I just want to give you a little bit of heads up on what you might encounter in your first exam. So it'll be 3 questions long, 3 to 4 questions long, probably 3, with a 90-minute time limit, and you'll be able to have your calculator with you, but it will be closed book. The only other thing you can have with you is some scratch paper and one 8.5 by 11 sheet of handwritten notes. So a normal size piece of paper, you can write front and back, you can write whatever notes that you want on that piece of paper. It just has to be handwritten, and you'll scan and submit it with your exam. Your exam will be taken online through our D2L, and I'll email you more directions and things about the specifics, but let's talk about what will actually be on it. So we're going to be covering in the exam chapters 1 through 3 in our textbook, which is everything we've done in the first 4 weeks. So this goes through statics, stress strain, and stress strain diagrams. We won't go into some of the axial load stuff that we've done. That'll be on the next exam. So for this one, it stops after the shear stress and strain diagrams. That'll be the last topic on this exam. So some things you should know to kind of prepare you for this exam: you'll want to definitely be very, very solid in your statics. I won't ask any explicit, like, find a centroid kind of question, but you might have to solve for reactions, solve distributed loads, find things in equilibrium to get to whatever strength of materials problem, finding a stress, so you might have to find a normal force in a rod in order to find a stress, right? So you'll need to know those equilibrium equations, finding loads, and then very importantly, the internal forces. Internal forces, specifically how to find your moment, normal, and shear forces. Those are going to be really, really important. And then we'll actually go into more of the strength of materials, the new material kind of stuff. So stress and strain are really the primary topics of the exam. So for stress, you have your normal stress, being your normal force over the area, as well as shear stress, being the shear force over the area, and then how we can use those with a factor of safety. So your safety factor being the failure stress over the allowable stress, and how we can use that for design. So being able to use these 3 equations very fluidly together and with the safety factor. Then with those, we'll also need to know the strain equations. So your strain equation for normal strain is going to be the displacement over the initial length. And your shear strain, gamma, is pi over 2 minus the angle of the shear. So understanding that those are different and how to find each of those, along with the idea of the small angle theorem, where you can use this S equals theta R as a shortcut to a lot of your, angle solving things. You don't have to know that explicitly as a, I'm not going to test you explicitly on that. Just know that this is going to be a shortcut that'll save you some time if you need to calculate angles and things like that. And then finally, the huge topic on this exam is going to be stress-strain diagrams. Stress-strain diagrams. We spent a pretty good deal of time on stress-strain diagrams. Again, it comes with everything before it, the stress and the strain. But really understanding how to read that diagram, picking out the important pieces of information. If I give you one of these, can you find the ultimate stress? Can you find the modulus of elasticity, right? What's the definition of a modulus of elasticity? How would you find that? Where is something yielding? How to know if something is yielding or not? Necking, what true stress strain versus actual stress strain. So all of these components that make up your stress strain diagram, know what they are and how to find them, how to pull them off of that, and then also work with your equations to find other things you might want to know, such as, Poisson's ratio, or that, which is the lateral strain over longitudinal strain. Modulus of rigidity, modulus of toughness, modulus of resilience. Knowing the equations for those, how do we find each of those? As well as the equations, if they have those, right? So your modulus of rigidity, for example, comes from the shear stress versus shear strain. And the equations that relate those, much like Hooke's law relates stress and strain, modulus of rigidity, same deal, stress and strain, but can also be related to modulus of elasticity. What is it? I think it's 2 plus, sorry, I just had this written down. Where did modulus of rigidity is somewhere. Okay, well, I thought I had this somewhere. It's like 1 plus Poisson's ratio times 2 or something like that. You'll have to look that one up. So the modulus of rigidity or shear, modulus of elasticity, shear stress strain diagram, Poisson ratio, and then using all those things together to find displacements or stresses or strains, any one of those components.